Sorry. Yeah.
Hello, everyone. My name is Jinhe Shi. I'm a PhD candidate at New Jersey Institute of Technology. My research focuses on the developing machine learning, deep learning technologies on healthcare applications. So today I will present my model for Equimus AI challenge. It is the user review prediction by CLSTM attention. So first I will share some background of the user review. According to an online survey, 92% of users will say that the positive review will make them trust a local business more. And 88% of the customers will trust online reviews as much as personal recommendations. And also 90% of customers will read online reviews before they purchase online. And also the 86 people will hesitate to purchase if the review is negative. So the user review prediction is really important. Our goal is trying to predict a review is positive or negative, because a negative review is much more important for companies. Companies need to get those feedback to improve their servers. So I built a deep learning model to classify the input reviews into negative or positive, compared with the traditional feature-based machine learning model like the SVM or random forest or something else, the feature-based machine learning model. So traditional feature-based machine learning model need to design a feature engine to extract some features, some important features from text, like if the text contains the positive words or the text length. So, but the problem is we cannot make sure we can cover all the features from the input text. So the deep learning model, deep learning do it a different way. It can learn the feature automatically. So my model contains the 6 layers. The first layer is the embedding layer. So the embedding layer tries to convert words into vectors. Each word will be represented as a vector. So similar words with similar words, that means similar words with similar meanings will have similar vectors. This is a word-to-vector. So you can use the pre-trained vectors like the word-to-vector provided by Google or the Grover provided by the Stanford University. Also, you can train your own word-to-vectors by applying the prediction model like the continuous back of words model or skip-gram model. So it will tells you each word, which vector it is. And when we have the vectors, so for example, if the sentence, if your the text review has 100 words, so this review will be represented as a dimension like the 100 times 100 vectors. And now we have the vectors. The next step is to capture features. As I said, traditional machine learning method will design a feature engine to extract these features, but the deep learning will learn the features automatically by I add a convolution layer to calculate the feature maps. So when we get the different feature maps, we want to pick up some the most important features. So I add a pooling layer. So I add a max pooling layer to pick up the most important features. And when we get those features, I feed it into a LSTM layer. So the LSTM is a kind of recurrent neural network. It can learn the dependence among the features. It can handle the sequential data. So I add a LSTM layer to get the dependency features between these features. So some review text is very long. It may contain hundreds of words. So on the top of LSTM layer, I add an attention layer. Attention layer means I try to make the model to focus on those important words. So I add attention layer to focus on the most important features. So after I get those important features, I add a softmax layer to output the binary output. If the reviewer if the review is positive or negative. So this is my model. So the input of my model is the unstructured review text, and the output will be tell you if the text is positive or negative. So how to use the model? If you want to use the trained model, you can directly input your text review. You can write down a review text, and my model will tell you, my trained model will tell you if the review is positive or negative. Also, you can train the model on your own data set. If you have a training data set, like if you have labeled training data set, you can use your own data set to train the model and test your own data set. Yeah. Do you have a question?
Had you used? I have a question. So, had you used this this methodology before on different problems, or did you derive it specifically for this language problem?
I designed the model for. It's a similar like the I use this model to extract the patient disease from the clinic notes.
Oh.
Yeah. So I designed this model a year ago we all know the clinic notes contains the patient disease mentions. So our goal is to extract the patient disease mention from the clinic notes. I designed this model to classify if the sentence mention is positive or negative. So when I know this competition, I know I can apply the model to the user review prediction. It is a similar domain, and and also the user review is very important for companies. Okay. Sorry,
so the question was, what's the C in CLSTM?
CLSTM. So as I said, I add a convolution layer before the LSTM layer. So it's called the CLSTM attention. Yeah, convolution CLSTM attention.
What is the percentage of false readings?
Yeah, so I trained the model on the IMDb movie. It's a movie review text. It contains 50,000 reviews, and the positive and negative is about 50%. There are 50% negative reviews and 50% of positive reviews.
Do you correlate it to the rating, like 0 to 10?
This IMDb review text is a public available data set. It already tells you the review is positive or negative. One, this has two labels. One means the positive, and 0 means the negative.
Right. No, yeah. But I was wondering, like, since those reviews on IMDb have a number associated, can you compare your conclusion with the rating, the number rating?
Yeah. So now the performance, the accuracy is about 90%. 90% accuracy.
Sorry. No, how did you select the parameters for your model? Did you take them from literature, or did you?
I took it from the literature, and also for the convolution layer, we tried different filters. We tried the filters of 3, 4, and 5 to try different feature size and get different feature maps too.